let's do some more absolute value equations. Let's solve, so let's find the solution set for problem number 1. The absolute value of 3x minus 2 is equal to 14. Now remember, the absolute value can only be solved if it's equal to a positive output. So whatever I do, I take the inside, right? I split it up into two cases. So I've got 3x minus 2 is equal to 14, or 3x minus 2 is equal to negative 14. Okay, I'm going to solve for both, and here we go. So 3x minus 2 is equal to 14. Let's solve for x. I'm going to undo the layers of x by undoing that minus 2 layer. I'm going to add 2 on both sides. So I get 3x is equal to 14 plus 2, or 16. 3x is equal to 16, which means I need to divide both sides of the equation by 3. Now, x can equal 16 over 3. That's going to be a decimal, so I would leave this as 16 thirds. However, if you are partial to decimals, it's okay to write this as 3 goes into 16 5 times with 1/3 remaining. So that would be 5.333333333333. So you would put a repeating symbol on the 3. So 5.3 repeating. Remember, this is one of the solutions. Even though they're two different formats, it's the same number. So let's solve for the other side. 3x minus 2 is equal to negative 14. I'm going to undo the outer layer by adding 2 on both sides. Okay? Now, I've got 3x is equal to, what's negative 14 plus 2? Negative 12. So if 3x is equal to negative 12, I'm going to divide both sides of the equation by 3. So x is equal to negative 12 over 3. Hey, that is a whole number. It is x equals negative 4. So one of the solutions is negative 4. The other solution is 16 thirds, or 5.3 repeating. See if you can do number 2 independently. The absolute value of 8x plus 4 is equal to 36. Is this problem solvable? Well, I have to account for both directions. 8x plus 4 is equal to positive 36, or 8x plus 4 is equal to negative 36. So I'm going to split them into two equations, and I'm going to solve for them independently. So let's solve for the right part of the equation. How do I undo the layers of x in this problem? Well, I'm going to subtract 4 from both sides. So 8x is equal to 36 minus 4, which is 32. So 8x is equal to 32. I'm going to divide both sides of the equation by 8. That cancels out. Now we've got 32 over 8, which is 4. So that's one of the solutions. Let's solve for the other. So I've got 8x plus 4 is equal to negative 36. And now I'm going to undo the layers the same steps. I'm going to minus 4 on both sides. So I get 8x is equal to negative 36 minus 4, which is negative 40. I'm going to divide both sides of the equation by 8. X equals, what's negative 40 divided by 8? That's negative 5. So it's both of them being whole numbers. I like it when they're both whole numbers. So either way, if I plug in, so when I'm going to check my work with this because it's whole numbers, it's much easier. 8 times 4 is 32. 32 plus 4 is 36. The absolute value of 36 is, in fact, 36. Now I'm going to plug in x equals negative 5. 8 times negative 5 is negative 40. Negative 40 plus 4 is negative 36. Therefore, the absolute value of negative 36 is, in fact, 36. Both of these solutions get the same output. Now I'm looking at number 3. The absolute value of 7x minus 3 is equal to negative 24. Is this problem solvable? Well, the absolute value is equal to negative 24. There's no such thing as negative distance. So if the absolute value bars equal a negative output, this problem is impossible. So therefore, x has no solution. Okay. Moving on to problem number 4. Now this one's a little bit different because it could be rephrased as negative 5x plus 1 if that's what makes you feel better. But the absolute value of 1 minus 5x is equal to 34. Is this problem solvable? Yes, because the output is positive 34. So I'm going to account for both directions my expression can go. So the inside can be 1 minus 5x is equal to positive 34, or 1 minus 5x is equal to negative 34. So I'm going to account for both sides of the equation. So let's start with the right side, since I'm a positive person. 1 minus 5x is equal to 34. So I'm going to undo the layers by minusing 1 on both sides. So I subtract 1 from both sides and I get negative 5x is equal to 34 minus 1. 34 minus 1 is 33. Negative 5x is equal to 33. Now, if I plug in, if I want to undo the layer of x, I'm going to divide both sides of the equation by negative 5. So x is equal to, we've got a positive divided by a negative, so that's a negative. 33 over 5, well, that's going to be a decimal. You can leave it like this if you'd like, but the alternative is, what if you don't like improper fractions? That's all right with me. 5 goes into 33. Well, I know 5 goes into 36 times, so this is negative 6. With a 3 remainder, 3/5 is 0.6, but it's not repeating, so I'm not going to put a hat on the decimal. So it's negative 6.6. The other way is 1 minus 5x is equal to negative 34. Okay, so now I'm going to subtract 1 from both sides. And I'm going to get negative 5x is equal to, that's negative 34 minus 1, that would be negative 35. Negative 5x is equal to negative 35. And I'm going to undo that final layer by dividing both sides by negative 5. So that means x is equal to negative divided by negative is a positive, 35 divided by 5 is positive 7. So the two solutions are that x can be equal to 7 or negative 6.6, or negative 33 over 5. So now, moving on to problem number 5, see if you can do this problem independently. The absolute value of 8 minus 3x is equal to 22. Okay, so is this problem solvable? Yeah. Because the output is positive, I'm going to split this into two equations. 8 minus 3x is equal to 22, or 8 minus 3x is equal to negative 22. So let's start with the right side, since I'm a positive person. So I've got 8 minus 3x equals positive 22. I'm going to undo those layers by subtracting 8 from both sides. So I get negative 3x is equal to, well, 22 minus 8. 22 minus 8, that'd be 14. So negative 3x is equal to 14. I'm going to divide both sides of the equation by negative 3. So that means 14 divided by negative 3, a positive divided by negative is a negative. 14 over 3, that's a decimal. So I can leave this as negative 14 thirds, and I'm okay with that. If you love decimals for some reason, you can write this as, well, 3 goes into 12, 3 goes into 15, so that means that 3 goes into 12 4 times. And that's going to be with a remainder of 2, so that'd be negative 4 and 2/3, or negative 4.6666666666666. So I put a repeating symbol on the 6. So negative 4.6 repeating. Look at the other side of the equation now. I've got 8 minus 3x. Sorry, I want the lighting a little bit better. There we go. 8 minus 3x is equal to negative 22. So I'm going to subtract 8 from both sides. And I'm going to get negative 3x is equal to negative 22 minus 8 is going to be negative 30. Okay. So now I've got negative 3x is equal to negative 30. I'm going to undo that final layer of x by dividing both sides by negative 3. So that means x is equal to negative 30 divided by negative 3. That's going to get me a whole number. Negative divided by negative is a positive, so 30 divided by 3 is positive 10. Okay? Number 6. The absolute value of 6 minus 3x is equal to negative 15. See if you can do this problem independently. Well, first things first, is this problem solvable? No, man, that absolute value can't equal a negative output. So since the absolute value bars can never equal a negative output, there's no such thing as negative distance. This means that x has no solution. So this problem cannot be solved. Okay. Turn the page. All right, we've got 2 more, and we'll call it a day, just to get us familiar. All right, sorry about that light. Oh man, the light is a little bit off. Okay, there we go. Focus. Let's see if you can do number 7 and number 8 independently. So the absolute value of negative x minus 4 is equal to 10. Is this problem solvable? Yes, because the output is positive, I need to account for both cases. So I've got negative x minus 4 is equal to 10, or negative x minus 4 is equal to negative 10, because I need to account for forwards and backwards. But there's no coefficient in front of x. What can I do to calm my nerves? I'm going to put a 1. So specifically, this is negative 1x minus 4 equals negative 10. And this is negative 1x minus 4 is equal to positive 10. So I'm going to, let's solve this problem now. I'm going to undo the outer layer by adding 4 on both sides. Therefore, I've got negative 1x. 10 plus 4 is 14. Negative 1x is equal to 14. If I divide both sides of the equation by negative 1, x is equal to negative 14. But that's not the only solution. I'm going to put a big old or in the middle. remember, I'm going to undo the layers by adding 4 on both sides. If I add 4 on both sides, I'm left with negative 1x is equal to negative 10 plus 4 is negative 6. So now I've got negative 1x is equal to negative 6. I'm going to divide both sides of the equation by negative 1. And that gets me x equals negative 6 over negative 1, which is positive 6. So if I plug those into the expression, so I plug those into the equation, let's start with negative x. Well, I'm going to plug in x equals 6, and I'm going to get negative 6, so negative 6. Negative 6 minus 4 is negative 10. The absolute value of negative 10 is, in fact, 10. But let's try the other one. Even though there's a negative in front of the x, pretend it's like times negative 1. Or if I plug in negative 14 in there, I get negative 14. I'm not teaching on an iPad right now. So negative 14 is positive 14. Positive 14 minus 4 is positive 10. And the absolute value of positive 10 is 10. Therefore, x equals negative 14 is okay as well. That's my thumbs up. 12 minus x in the absolute value bars is equal to 30, and that'll be our last problem of the day. Okay, so let's take a look at this. Okay, is this problem solvable? Yeah. So I'm going to split this into two equations, 12 minus x is equal to 30, or 12 minus x is equal to negative 30, because I need to account for forwards and backwards. Right? So once again, there's no coefficient in front of this x, so I'm going to calm my nerves by making this 12 minus 1x. Okay, now I'm going to undo the layers. Let's minus 12 on both sides. 12 minus 12 cancels out. I'm left with negative 1x is equal to 30 minus 12. Well, 30 minus 10 would be 20. Subtract 2 more, that would be 18. So negative 1x is equal to positive 18. I want to undo the layers. Remember, I want positive 1x. I don't want negative 1x. So I'm going to divide both sides of the equation by negative 1. And that gets me x equals 18 divided by negative 1. That's going to get me negative 18. All right, I'm going to check over here. 12 minus x is equal to negative 30. So now I'm going to subtract 12 from both sides of the equation. Oh, I forgot. I like that negative 1x. So negative 1x is equal to negative 30 minus 12. Adding negatives, so I'm going further down. Negative 1x is equal to negative 42. And if I divide both sides of the equation by negative 1, x is equal to negative divided by negative, that's positive. Negative 42 divided by negative 1 is positive 42. Check my work one last time. If I plug in x equals 42, 12 minus 42, that's going to be negative 30. The absolute value of negative 30 is 30. And finally, if I plug in negative 18 as in 12 minus negative 18, I'm plugging in for that variable. That's 12 minus negative 18 or 12 plus 18. 12 plus 18 is 30. And the absolute value of 30 is 30. Hope you guys enjoyed this. We're going to have one more review day on this, and then I'm going to Google share with you the exam for the solving absolute value equations in 2 steps. So one more review day. Then test. Have a great day.